First question says a 1.95 times 10 to the 3 kilogram car is traveling north at 72 kilometers per hour. The magnitude of the momentum, I don't know what that is. Momentum? I think it should say momentum. The magnitude of the momentum of the car is what? Pretty straightforward question, but I'm going to put down the blue pen and pick up the red pen because there's something that I should draw attention to. What is it? What do I want to draw attention to? Circle to avoid, or highlight with a yellow highlighter or whatever, just to avoid making a silly mistake. Alex? Kilometers per hour, good. You should do this tomorrow if there's units of kilometers per hour or grams or mistake. But you're more likely to make the mistake if you don't draw attention to it than if you do draw attention to it. And I mean, how hard is it to circle kilometers per hour, right? You might not have a red pen. You might have to do it in your blue pen, whatever. Doesn't matter how you draw attention to it, as long as you draw attention to it to avoid making that silly mistake. All right, so we've got a mass here of 1.95 times 10 to the 3 kilograms, and we've got a velocity of 72 kilometers per hour. I'm going to convert that velocity of 72 kilometers per hour to meters per second. Do you remember the conversion factor that we're going to use for that? Yeah, we're going to divide by 3.6, which gives me 20.0 meters per second. Now, this is a really straightforward question now, right? Now that we've got kilograms and meters per second, it's really straightforward, okay? Make sure, though, if your velocity is not in kilometers per hour, in meters per second, put it in meters per second. And if your mass is not in kilograms, put it in kilograms. I think I asked you this question already, but does anybody have chemistry period 1? You guys in particular, okay, watch out for kilograms and grams, right? Okay, if it's grams, you guys are going to be in the habit or kind of in the mindset of using grams when you come to physics class. You want to switch that mindset to put it into kilograms, okay? If there's that conversion to do. Tomorrow or any other time for that matter. All right, so let's multiply that mass of 1.95 times 10 to the 3 kilograms times that velocity of 20.0 meters per second. I'm not going to forget to use the 20 meters per second because I drew attention to it, right? I'm almost guaranteed of using the right number now. Let's multiply those two numbers together. 1.95 times 10 to the 3. By the way, lots of you guys, when you type in scientific notation on your calculator, will do this. 1.95 times 10 to the, this little hat button there, 3. Don't do that. That's not the way that the people that made their calculator or designed the calculator ever intended you to enter scientific notation. Don't do it that way. Okay, that will work, okay, if you use brackets properly throughout a problem. But the way that they intended you to do scientific notation, you don't need to use brackets to use scientific notation. We're going to say 1.95, second function, hit this little EE button right here. It's the second function, comma, EE3. That's the way you should enter it. Then if you're dividing by something that's in scientific notation, you don't need to worry about brackets on the bottom. Okay? It assumes that that whole thing is in brackets already. If you don't do it this way, if you do it the other way, then you have to add brackets. And you can do that. It'll work. But again, it's one more thing that can go wrong for you, right? One more little thing that can go wrong for you. You know how to do a question, you enter it wrong, and you get the wrong answer. Multiply that by 20. We get an answer of 39,000, which is 3.90 times 10 to the 4 kilograms meters per second. Or the other set of units we could have used there would be Newton seconds. Kilograms meters per second and or Newton seconds. Okay, good. Number 2, 145 gram baseball is moving at a speed of 27 meters per second when it's 2.5 meters above the ground. What's the magnitude of the momentum the instant that it strikes the ground? I'm going to pick up the red pen. Tegan, what do I want to draw attention to in this one? Good, the grams. We have definitely got to convert that one to kilograms. That mass is going to be, what's the conversion factor? Is it 100 or is it 1,000? Yeah, it's 1,000. If you don't remember that, you probably will because you've used that enough times over the years. But if you don't remember it, that's okay. It's on your data sheet. Check the back of it. It says the conversion factor is 10 to the 3 or 1,000. Kevin, am I going to multiply that by 1,000 or divide? Yeah, so it's 0.145 kilograms. Now, if you guessed multiply, that's okay, but just check your guess to see if it's reasonable, right? 145,000 kilogram baseball would not be reasonable. So it is divide, you're right. All right, the magnitude of the momentum the instant before it strikes the ground. This is one of those momentum after acceleration problems, right? We want to find PF using m times VF, but we've got to find VF. What's the final velocity? Not the final speed. What's the final velocity? How am I going to find that? Yeah, that's the one that it seems like we use most often. Don't assume that it will always work. It's never going to give you the wrong answer. Like if you try that in a situation like this, the worst case scenario is you end up with 2 or 3 unknowns and you just can't use it. And you just got to try another one, right? But don't force it to make it work. If you're missing a couple variables, all right, just move on to another acceleration equation. I think we used A is equal to delta V over delta T in one of them yesterday, right? Any of those acceleration equations. All right, solve for VF here. Okay, 2 common mistakes that we can make here at this point. The first common mistake that people make is to say VF squared is equal to 2 times neg 9.81 times neg 2.5. What's wrong with that? It's wrong. What's wrong with that, Marshall? VI, right. We can't forget the VI. So VF squared is equal to 27 plus 2 times neg 9.81 times delta D of negative 2.5 meters, and then we square root that. Good? I just made the other common mistake that people make. What is it? We need to square the 27. People get it's almost like they get excited, like, hey, I didn't forget the 27, I didn't forget it. And then, oh, I forgot to square it, the 27. Okay. I don't think in this question that forgetting the square gave you an option there. So if you did forget the square, you would have found, oh, that option's not there. I'll try again. That's not always going to be the case, right? A lot of times, if you forget to square that 27, the option's going to be there. All right, so let's do this here now. Let's say the square root of, depends on what version of the calculator you use. In some of the versions, you actually don't need brackets here. In some of them, you do. In this one, you don't need brackets. But I'm going to encourage you to use brackets here anyways, just as a matter of good habit. Okay, the square root of everything inside the brackets. 27 squared plus, I'm going to use brackets again, 2 times neg 9.81 times negative 2.5. End the bracket. Am I good? Now I got to end the bracket, the outside brackets there, right? Oh, 2, so it's times, right? Thank you. I think that's good. 27.8935. Oh man, I should have made that an option here. Because how many people would have been like, oh, I see 27.89, I got it. And then just not finish the question, right? This is the final speed. We want the final momentum. Remember, the final speed is 27, the final velocity is negative. But in the end, since I'm only looking for the magnitude of the momentum, it actually doesn't matter here, right? The direction doesn't matter. So if you don't sub in the negative there, it's okay in this case. Now, if we were looking for the momentum, not the magnitude of the momentum, but the momentum, then we'd have to sub in the negative value. All right, so 0.145 kilograms times that number, 27.7, 27.89, I should say, gives me a value of 4.04. Answer is going to be B for that. And 3, which of the following units are correct units for momentum? Which one is it? C, Newton seconds. And the other one, not listed here as an option, but the other one is what? Kilograms times meters per second. Kilograms times meters per second. So Newton's times seconds, not Newton's per second. Newton times seconds. Okay, this would be Newton's per second, and that would be wrong. And then we've got kilograms times meters per second, or this. All right. Number 3 again. This should be number 4. 2 kilogram cannonball is fired out of a cannon at an angle of 30 degrees to the horizontal. When the cannon reaches the top of its path, its momentum has a magnitude of 800. What's the horizontal component of the momentum when I left the cannon? This is a tricky question, but when you see the answer and you see the thought process, it's like, oh, seriously? I missed that? If you missed it, that is. Some of you didn't. What force is acting on this cannonball after it leaves the cannon? What force or forces act on it? Not like while it's being released, because clearly while it's being shot, the cannon acts on it, right? But after it's released, what force or forces act on the cannonball? Got it? Gravity. Yeah, which acts which way? Down. Good. Gravity acts down. Marshall, is there anything else that acts on it? Besides gravity? Yeah, inertia is not a force though, right? Inertia is just the tendency to keep doing what it's doing. It's a tendency. In the absence of air resistance, there is no other force acting, just gravity. So because of gravity, this thing is going to speed up and slow down vertically, right? As it goes up into the air, it slows down. As it comes back down, it speeds up vertically, right? Just like a ball you throw straight up into the air. But horizontally, if there's no forces acting, why would it speed up or slow down? So horizontally, it's going to maintain the same motion, uniform motion horizontally, or constant velocity. If its velocity doesn't change horizontally, then how does its momentum change? It doesn't. So the horizontal momentum rate here is 800. What's the horizontal momentum rate here? 800. It hasn't slowed down or sped up horizontally. It has vertically, but horizontally, it doesn't speed up or slow down. So the horizontal momentum is going to be 800 anywhere along the path. That's our answer, B. There's no calculation to do that. Okay? Some of you may have thought back to Physics 20, projectile motion. Remember that? Remember when we had projectile motion, we described the x component by v equals d over t and the y component. You're not going to have to do a projectile motion question in Physics 30, but does that ring a bell? Yeah? Horizontally, constant velocity, right? If it's constant velocity horizontally, then it's constant momentum horizontally as well. Okay, and number 4 here, or really it's number 5. A 1,200 kilogram car traveling north at 20 collides with a 1,000 kilogram car traveling south at 24. What's the total kinetic energy and the total momentum of this system? All right, let's do kinetic energy first. There's 2 objects, so it's 1/2 m1 v1 squared plus 1/2 m2 v2 squared. Even though some people like to cancel out the half here. Don't do that. Why can't you cancel out the half? It's in every term, isn't it? Can't you cancel out anything that appears in every term? Yeah, it's an addition equation, but that you can still cancel things out in an addition equation sometimes. Yeah, and that's okay though. Yeah, it's the same number. It's okay. Ben? Yeah, there's 3 terms. It's in every term on the right side, but if it said 1/2 EK, if 1/2 was on the left side, then you could cancel it out. Even though it's in 2 terms on the right side and only 1 on the left, it has to be in every term in the equation, left side and right side. So don't cancel that out. Okay, don't. What do we got here? Half of 1200 times V1, which is 20 squared, plus 1/2, whoops, plus 1/2 of 1,000 times negative 24. Is that right? No. Why are we not putting the negative in there? Yes, yes. Kinetic energy is a scalar. Good. Right. So we have to include the negative for velocity, for momentum and velocity, but we don't include it for kinetic energy. So let's use some brackets here. 0.5 times 1200 times 20 squared plus some more brackets, 0.5 times 1000 times 24. Whoops. Ooh, almost made a mistake there. I almost did that. What's wrong with that? Yeah, I don't want to square that whole thing, right? I want to square just the 24. I think that's good there now. 528,000. So that means the answer is either going to be A or B, right? 5.28 times 10 to the 5. What about momentum now? The total momentum would be M1 V1 plus M2 V2. 1200 times V1 plus 1000 times V2. 24. What's that equal? 12. Let's use some brackets again. 1200 times 20 plus brackets again, 1000 times 24. Gives me a value of 48,000. So the answer is going to be A, right? What's wrong? Yes. That's going to be negative 24. We do include the negative this time, right? Because momentum and velocity are vectors. Vectors, right? If you ever forget whether something's a vector or a scalar, right? You just check that data sheet. Little arrow over it, vector. No arrow, scalar. All right, let's change this then. It must be, the answer must be B then, but let's just double check that. Let's insert a little negative in there. And look at that, there we go. We get 0. So sure enough, the answer is B. 5.28 times 10 to the 5 joules and 0 kilograms meters per second or Newton seconds. Good? Yep. All right.